Okay, so I hope everybody is doing well. As you know, today is our last class. Maybe the last 10 minutes it will be for discussion, questions and answers. If you have any questions regarding your final exam or anything related to this course, okay? So guys, let's continue first. I want to start teaching, and after that, maybe the last 15 minutes or 10 minutes, we will have time for discussion. So yesterday we were talking about two different special logarithms, right? That is common logarithm and natural logarithm. And we did a few examples related to these two special logarithms, right? So that's the last thing we are going to learn today and in this course. Change of base of logarithms. And also that is one important, how to say, let's say, concept that is used in a lot of applications or in solving problems. Okay, so here we can find the value of a logarithm to a base other than 10 by changing the base to 10. Sometimes we may have to change the base of the logarithm, right? Especially solving the problems. If you want to convert your logarithmic equation into exponential, first you have to simplify this. To simplify this, we have to use some properties of logarithms, right? Like addition or multiplication of product rule or power, right? And we actually already studied a few properties. One of them is this. If you're given this logarithm of b to the base a. Okay, logarithm of b to the base a. How can I just write this as the logarithm of to some different base? Let's say it is c. So that actually says that here logarithm of b to the base a is exactly equal to logarithm of b to the base c, or logarithm of b to the base c, or also is equal to this. Okay, first I will start from this part. Let's say y, actually these two things are equal to each other. Okay, so proof is not so simple, not so difficult, but sometimes when I ask this question to the class, and give them like 5-6 minutes, most of the time, most students could not actually prove it. They cannot get this thing using this thing. Okay, so let's say this thing, logarithm of b to the base a. Let's say is equal to something, right? Let's say it is y. We just denote with y. Logarithm of b to the base a. Okay, so using the definition, now keep in mind that we just label this thing by y, okay, because it's something here, right? We have a number. Now, how about if I take the logarithm of both sides to the base c? Right, we can do this. If you do the same thing to both sides of the equation, it does not change the solution of the equation, or it just produces equivalent equation. So here we have logarithm of y to the base c equals, wait, Chinkoi. Okay. First, actually, I just convert this into exponential form. So here we have a. Here we have a to the power y, right? It's the base. It's the exponents, right? So a to the power y is equal to b. All right. So now from here, if I take logarithm of both sides to the base c, what we have here? Logarithm of a to the power y, and here we have the base c, and here we have logarithm of b to the base c, right? We just did the same thing to both sides. Okay, now using that property, we know that it's the exponent, it comes to the front, right? So I can just write it as y times logarithm of a to the base c is equal to logarithm of b to the base c. So now if I divide both sides by this expression, what we get here? Here we get y equals logarithm of b to the base c over logarithm of a to the base c. Okay. So what is y? Y equals this thing. So I can just write at the same time that thing is equal to logarithm of b to the base c. Okay, now special case. In this case, this is the first part. How about, because c can be anything, right? Any possible number, any number. So how about if I take this c as b? Assume that c equals b. Then what we have here? So here we will have, or what is this? Here we will have logarithm of, this one is a, right? Here we will have logarithm of b to the base a, this thing, right? That is equal to this thing. So here we have logarithm of, what is b? B and c, they are equal to each other. So b instead of c, I can write b over, and here we have logarithm of, what do we have here? A to the base c. What is c? C equals b. So it is equal to b. And we know that logarithm of b to the base b is equal to 1. So here we have 1 over logarithm of a to the base b. Okay? And also again, how we are changing these two things. That means that logarithm of a to the base b times logarithm of b to the base a, that's equal to 1. Example for this, change of base of logarithms. Find the value of logarithm of 7 to the base 5, giving your answer correct to 4 significant figures. Okay, that means that here you may again wonder, actually we have a calculator, immediately we can just key in this thing and we can get the value of this thing. That's fine, but here we are assuming that you have, actually you are given some kind of special table here, okay, and you know the value of, for example, LG7, and also you know the value of LG5, okay. So now, if you know this, how can I get the value of this thing? It's a bit classic question, or you need to evaluate this without using a calculator. Okay, that means that we may want to measure your knowledge about using logarithm, or how to say, using its properties. Anyway, here we have logarithm of 7 to the base 5, right? I can change this to any base if these things are given. So I can change the base to 10. So I can write it as LG7. It means that here the base is 10 over LG5, right? Base is C, here say is 10. That's why it's a common logarithm. I'm not writing this. Or even I can just write it as natural logarithm of 7 over natural logarithm of 5. Or anything here, we can write it as natural logarithm of anything, right? Since we have a formula, these bases must be equal, so they are always equal to each other. Okay. So now, using this thing, or this thing doesn't matter, we can evaluate this. So, where's my calculator? Okay. Correct the 4 decimal places. That is logarithm of, here we have 5, we have 7. So that thing is equal to 1.20906 something. So it says here 4 significant figures, starting from the first non-zero number, digits, right? 1, 2, 3, 4. So we have to keep these digits. After it is equal to 0, so I can delete these digits. So here we have the answer, correct, of 4 significant figures. Okay. Another example, change of base of logarithms. Solve the following logarithmic equations. Okay, starting with A. So here we have logarithm of y to the base 3 plus logarithm of y to the base 9, which is equal to 6. Okay. So I can change its base here, logarithm of y to the base 9. right? Here we have 3. How can I have here in the base 3? So I can just write it as logarithm of y to the base 3 over logarithm of 9 to the base 3, right? This is b, this is a, our base is 3, which is equal to logarithm of 9 to the base 3. We know it is equal to 2 because 2 squared equals 9, right? So here we have 1 over 2 times logarithm of y to the base 3. So now if I substitute here, logarithm of y to the base 3, right? Plus this thing equals this, 1 over 2 times logarithm of y to the base 3 equals 6. So now logarithm of y to the base 3 is a common factor. You can just extract this and keep it out of the parentheses, y to the base 3. Here we have 1 plus 1 over 2, that's equal to 6, right? Or logarithm of y to the base 3 equals 6 over, or divided, what we have here, 3 over 2. 3 over 2, which is equal to 2, 12, that's equal to 4. Now from here, what is y? Y equals 3 to the power 4, which is equal to 81. So the solution of this equation is 81. Okay. How about another example? Let me solve B on. Okay. All right. A is done here. Now let's solve B. All right, B. Logarithm of x to the base 4 equals logarithm of 4 to the base x, right? So what we can do here, again, logarithm of 4 to the base x, right? I can write it as logarithm of 4 to the base 4, or we just know that actually this thing is equal to 1 over, we have just proved it, logarithm of x to the base 4. Right? So let's say here w is equal to, not w, should I? Anyway, even we don't have to, I think. Okay, now if you substitute here, we have logarithm of x to the base 4 equals 9 over logarithm of x to the base 4. Now if you take to this side, what we have here, logarithm of x to the base 4 squared is equal to 9. Okay, here we have something squared equals 9. Now I know how to solve this, right? Because by factorization I can solve this. So it is logarithm of x to the base 4 equals 3, or logarithm of x to the base 4 equals negative 3. So from the first one, x equals 4 cubed, which is equal to 64, or here we have x equals 4 to the power negative 3, which is equal to 1 over 64. Okay. All right. Guys, that's all about logarithm. Now we are going to solve some questions from revision exercise 10. Okay. I have, by choosing some questions from each, not each, some questions, and after that, I will finish the class. I look for these qualities and characteristics in people. Okay. What qualities you are looking for in people? So honesty is number one, right? Everybody wants other people to be honest with you, not cheat, right? Respect, and absolutely the third would have to be loyalty. To be loyal to your parents, to be loyal to your friends, to be loyal to your peers or co-workers, whoever is it. Anyway, this one of my favorite codes. That's why I put here. Guys, continue. I'm going to open another slide here. Okay. So these are the questions from review questions 10. Okay. And we have a lot of questions here for practice. I'm not going to solve all of them. Maybe just pick one question from each question and solve. Maybe we are going to solve 8 questions. Okay. So I think I forgot to share this with you. Bulong, are you there?
Yes, sir. I'm here.
Very good. All right. So these are review questions 10. We are not going to solve every question. Okay. Let's choose one from each, which looks beautiful. And that much would be enough. So let's start from which one? Bulong, can you choose one question from here?
B.
B. All right, Bulong says B. Let's solve B. Next question, actually, it will be chosen by Mengnuch. Mengnuch, get ready for very hard question. It's coming for you. So here we have 9 to the power x plus 7 times, this means times 3 to the power x. I can just write it as 3 to the power x times 3 to the power negative 1. On the right hand side, we have 16. And also we know that 9 to the power x, it is 3 squared to the power x, or I can just interchange these two things. And here we have 3 to the power x squared, right? And here let's denote and use auxiliary variable to denote this 3 to the power x. And then what we have here, 9 to the power x, this one is w, here we have squared, so here we have w squared, plus, and we know that 3 to the power negative 1, it is 1 over 3, 7 over 3 here, we have 7 over 3, and here we have w. And take the 16 to the left hand side, here we have 16. That's equal to 0. Or this is a fraction, I can actually, if you want to have integer coefficients, let's multiply both sides by 3, then we will get 3w squared plus 7w minus 48 is equal to 0. Okay. First, we may try factorization. I'm not sure it works or not. If it doesn't work, then we can solve this by using formula. Let's say this one equals 7 squared minus 4 times 3 times negative 48, which is equal to, what is it, 49 plus 12 times 48. Oh, actually, we can solve it by factorization, no problem. It is 625. So from here, W1 equals minus B, that is minus 7 plus square root of 620. That is, we know that this thing is 25 squared. So here we have 25 over 2 times 3, 2 times 8. That's equal to 18, right? 18 over 6, that's equal to 3. And from here, what is W1? It is 3 to the power x sub 1. So from here, what is x sub 1? That's equal to 1. That's our first solution, right? Because 1, and here we have it is. Anyway, W2 equals negative 7 minus 25 over 2 times 3, which is equal to minus 32 divided by 2 minus 16 over 3, which is equal to 3 to the power x sub 2. And here we know that we have positive number raising to some power, right? It is never a negative number. On the left hand side, we have negative number. On the right hand side, we have positive number. So this thing has no solution, okay? So here, dot, 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 then the solution of the given equation is only 1. That's equal to 1. It has only one solution. Okay. Megnuch.
Yes, sir.
Can you choose one question for us from here? Which looks the most beautiful for you here?
I choose A, sir.
A. Did you say A?
Do you hear me, sir?
A or E?
I choose A.
Why did you choose A?
Okay, sir. I choose E, sir.
All right, that's the A is too simple, right? 2 to the power x, take the outside, 1 plus 4, it is 5, and you can solve this. So it's quite easy. Let's do E. Okay, here we have logarithmic equation. All right, here we have LG, 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 LG. Good, all the bases are equal. So here we have LG, right? Bring this inside. Here we have x plus 2 squared. Plus here we have LG4. On the right hand side, LGX plus, and also bring this here. Here we have LG 3 to the power 4, right? Now we can use the property of logarithm. Bases are the same and they are added. So that's equal to LG, right? This thing times this thing. That's equal to 4 times x plus 2 squared. On the right hand side, LG, 3 to the power 4 is 81. It is added, bases are equal. So here we have 81x, right? LG something, LG something. So we need to solve this equation to solve that logarithmic equation. 81x, right? LG, LG same, bases are same. Also for these things to be equal to each other, and also these things, right, should be equal to each other. Now from here, what do we have here? 4x squared plus 2 times x. 2x, it is 4x multiplied by 4, 16x. Here we have 4 times 4, 16. Minus 81x equals 0. Right? Let's simplify this. Here we have 4x squared. 16 minus 81, that should be minus 65x, right? And plus 16 is equal to 0. I think we can solve this by factorization, right? 4x times x. This one is 1 times 16. So it is minus. Let's put minus, minus. Cross multiply. 4 times minus 16, minus 64, minus 1. The sum is minus 65, right? 4x times x, 4x squared. Negative 1 times negative 16. That's equal to positive 16. So we can write it as 4x minus 1 times x minus 16. That's equal to 0. From here, x equals 1 over 4 or x equals 16. Right? So always make sure that these are suitable answers. When it's 1 over 4, we have no problem here, we have no problem here, so that is the answer. And also as a positive number, substitute here, so no problem. So dot, dot, dot. The equation has 2 solutions, that is 1 over 4 and 16.
Yes, sir. I get it, sir.
All right. Chinkui, are you there?
Yes, sir.
Chinky, it is your turn to choose a question. Here we have 3 questions. It's about simultaneous logarithmic equations, so we have to solve them together. Which one should we solve here? A or B or C?
I think B.
Yeah, well, that's what I was expecting. It's like a game, right? A, B, C. The middle one looks much better. Okay. All right, guys, we are going to solve B here. Here we are given simultaneous equations, but in the exam, if you don't practice, you cannot solve fast. You will not have much time. That's why you have to practice these questions. Anyway, so we are going to solve this question. What is it? Here we have 3, question B to the power P, right? And on the right hand side, we have 9 times 27 to the power Q. The second equation is logarithm of 7 to the base 2 minus logarithm of, what is it, 11 Q minus 2P and to the base 2. On the right hand side, we have 1. Okay, we have to solve this. As you know, to solve logarithmic equations, we need to convert them into exponential equations. Then we can solve it, right? The first part is fine. Here we can simplify this. 3 to the power P. On the right hand side, here we have 3 squared times this 27 is 3 cubed. So 3 to the power 3 cubed, right? The second one, bases are the same, but here it is subtracted, right? So we need to divide. Okay, here we have a logarithm of 7. Let's say 7 is divided by 11q minus 2p, and the base is 2. Here on the right hand side, we have 1. Right? One more step. The first equation is 3 to the power p equals 3 to the power, we can simplify this, 2 plus 3q. 2 plus 3q. The second one is, using the definition of logarithm, that's equal to 7 over 11q minus 2p is equal to 2 to the power 1. This is an exponent, this is a base, right? It is 2. Okay. So from here, bases are equal. So here we have p plus, not p plus, p should be equal to 2 plus 3q. And here we have 2 times 11q. It is 22q minus 4p should be equal to 7. What is it? We got here simultaneous linear equations, right? And you know how to solve this. That is very easy thing. Takes to the left hand side, p minus 3q equals 2. And this one is multiply both, okay, just keep it like this, minus 4p plus 22q equals 7. Okay, so let's solve this one. Here, multiply the first equation by 4. Then we will have here 4p and add them together is equal to 0. And here we have multiplied by 3 minus 12, add them together, it is 10q. Here we have 4 times 2, 8, 8 plus 7, that is 15. Now from here, what is q? Q is 1.5. Okay, we got the value of q. Now if you substitute here, also I will get the value of p, 1.5, right? Multiplied by 3, it is 4.5. Take to the right hand side, 2 plus 4.5, that is 6.5. That is another solution. So dots, dots, dots. The solution of the given equation is p equals 6.5 and q is equal to 1.5. Okay. All right, guys, let's have some break. It is around 7 minutes left. Okay, after 10 minutes, we will continue. Guys, if you have any questions regarding your final exam or anything about this, you may ask now, okay? Don't actually be shy, ask it now. If you're really shy to ask here, write actually in Telegram, okay? Because that's the last week. And next week will be prep week. You need to practice and prepare for your final exams. And on Tuesday, that is July 14th, right? July 14th, you will have final exam. As you know, final exam time is about 100 minutes, and you will have around 25 questions, okay? It is multiple choice or short answer required questions, okay? Have a break. After 10 minutes, we will continue.